Right, so I have this question which is coming from projectile motion or free fall motion. So it is saying a boy throws a stone vertically up into the air with a velocity of 6.0 meters per second. The stone reaches a maximum height and falls into the sea, which is 12 meters below the point of release. Calculate the velocity at which the stone hits the water surface. Take acceleration due to gravity to be 9.8 meters per second squared. So we have a person here. He projected an object upwards, and it reaches a maximum height here. So this one is the maximum height. Now at this maximum height, the final velocity is just going to be 0. So which means an object is going to fall with free fall motion. The only force which is going to act to an object at this point here, it is just going to be the acceleration due to gravity. So when an object is projected upwards, it moves against the gravity. So in this case here, acceleration is equal to the gravity, but when it is projected upwards, it is going to move against the acceleration due to gravity, which means for acceleration it is just going to be negative g. So which means when an object is projected upwards, it is going to move against the gravity. So you need to take the gravity to be negative 9.8 meters per second squared or negative 10.0 meters per second squared, like that. At this point here, an object is going to be dropped with free fall. Only the acceleration due to gravity is going to act on an object if we ignore the air resistance. So in this case here, when an object is falling down, we take acceleration due to gravity as a positive value, which is 9.8 meters per second squared as the positive value. Now, they are saying we need just to consider the velocity at this point of release. Okay, so at this point of release, we are having 12 meters per second, and the initial velocity here, so the initial velocity, it is just going to be 6.0 meters per second. Then the height here we have, so they are asking us to calculate the final velocity in this case here. So now since we have the initial velocity and also the height, then the last thing that we have, since this object is falling down, we are going to have the acceleration due to gravity, which is going to be the positive value, 9.8 meters per second squared. So we have three things here. We have the acceleration due to gravity, which is the positive one, the initial velocity, and also the height, which is this one here. So for us to find the final velocity, we are going to use this formula. So v squared is equal to u squared plus 2 multiplied by the acceleration due to gravity multiplied by the height. So our data here, we can just say we have the initial velocity, which is 6.0 meters per second. Then we also have the height, which is 12 meters. We also have the acceleration due to gravity, which is 9.8 meters per second squared. So we don't have the final velocity in this case here, but the initial we have, which is 6.0 meters per second. Then we need to put a 2 outside here, plus 2, which is this one here, multiplied by the acceleration due to gravity, which is 9.8, multiplied by the height, which is 12 meters in this case here. So 6.0 meters per second to the power 2, we are going to get 36.0 meters squared per second squared. Then plus 2 multiplied by the acceleration due to gravity, which is 9.8 meters per second squared, multiplied by 12 meters. I'm going to get 35.2 meters squared per second squared. So 235.2 meters squared. So we have 0.2 meters squared per second squared. So when I had 36 meters squared per second squared plus 235.2 meters squared per second squared, I'm going to get 271.2. So I'm going to get 271.2 meters squared per second squared. Now remember, here we are having v squared, so we need to find the velocity, not v squared. So I'm going to introduce the square root to both sides, so that this square root and this one, they are going to cancel each other. Then the final velocity is just going to be, so the square root of 271.2, it is just going to be 16.468 meters per second. So in this case, the velocity is measured in meters per second. Now to round this one off to one decimal place, it is just going to be, so V is just going to be 16.5 in this case here, meters per second. So this one is our final velocity for an object. So that was the last one. Thanks for watching.